Okay, so we want to start solving basically circuit geometry problems. We've been able to look at circuit theorems. We've seen about six of them or more. I cannot remember exactly how many, but we're able to see circuit theorems and understanding all those circuit theorems we're able to look at in the other video is what will really help us solve circuit geometry problems in this video. So if you were able to go through them, I'm sure you must have mastered them. If not, you can check it out again and try to master those theorems because they are really going to help you while solving any circuit geometry problem. So one thing I want to mention is that whenever you're given a circuit geometry problem, um, if you have all the theorems in your head, look out for where you can apply any of those theorems to get your desired result. Okay, so let's start with this first one. Now they asked us to calculate LON. They have given us MLN. So they have said MLN is 74 degrees, right? They have given us this angle here, MNL, MNL, which is 39 degrees. But now they want us to find LON. So angles LON is not given. Now, what is angles LON? So now this is where you actually have to start paying close attention to the circle or the question given to you. LON actually, they're talking about this point here. So there is actually an angle here. Now, what angle are they talking about? They're talking about an angle at the center of this triangle, of this circle. So basically, there is an angle here. And if you remember, which theorem have we discussed that has to deal with center of the circle or the center of the inscribed angle we're looking at? And if you remember very well, we talked about theorem 1, where we say 2 times the angle at the circumference is the angle at the center. Okay, so that is the beauty of remembering these theorems. So, but basically, where is the angle at the circumference? Now this is the angle at the circumference here. So this subtended angle, remember when we said the angle that subtends at the circumference, actually that is the one that is 2 times that angle is what we have at the center. So if you actually have to draw this diagram so that you see what the angle is like on the center, it will be something like this, although it's if we did that in this diagram here, it would have been would have spoiled the diagram. So we're just going to do that in a separate diagram so that you see the type of angle that we are talking about at the center. So this is so here. This is the subtended angle here. Now this angle here, okay, this angle here, that is the angle at the center. So LN. Okay, so why we did not do that in that other diagram is because we're going to cut the angles 74 and 39 into half, so which we do not want to mess up with. So basically, they're just talking about this, but since they did not put it in the question, you just have to figure out that they are talking about the center of the circle. So that is the angle we're looking for. But we need to know this first before we find this angle. Now, how can we know this angle here? If you go back to the question, you see very well that this is a triangle, right? This is a triangle. So angles in a triangle sum up to 180 degree. So we can sum up this, and this angle, let's call it x, to give us 180 degrees, and we can easily find x. So we can say 74 degrees plus 39 degrees plus x is equal to 180 degrees, right? Now, this is 113, I guess, plus x is equals to 180 degrees. So x is equal to 180 degrees minus 113. Okay? Minus 113, which is equal to 67 degrees. Right? So that means this x here is 67 degrees. Now, the theorem that will help us find LN is the theorem that says that 2 times LMN which is the angle at the circumference, is equal to LON. Okay, so that is what we're looking at. So for us to find LON, so angles LON would be equal to angles LON, sorry, would be equal to 2 times 67 degrees. Okay, and that will give us what? 134 degrees. Okay, so that is question one. We're done with question one. How would you really figure these things out? Well, it takes practice to be able to understand these things. The first thing we were able to do is for us to understand what LON is. Where is it in the inscribed angle? And we noticed that it was at the center. Now, noticing that helps us to remember that there's a theorem that talks about the center of an inscribed angle in a circle. And with that theorem, we're able to get that we need to find the angle at the circumference, which is here, and then we'll be able to multiply by 2 to get the angle at the center. Okay? Now let's move on to another question. Okay, so let's look at this question critically. It says in the diagram O is the center of the circle. So O is the center of the circle. Now if angle QRS is 62 degrees, find the value of angle SQR. Okay, so how would we do this? Remember, your theorems are what will help you in any circuit geometry problem, and maybe other knowledge in mathematics on angles and the rest. Okay, so first of all, they have said O is the center of the circle, and if you look at it, since they have told us the center of the circle is this, and you see the line here, it shows that this is the diameter. Now, is there any theorem? If you go back now, if you do not know the theorem, go back to any video or any textbook, check which theorem talks about the diameter or the center of the circle, a line drawn at the center of the circle and an angle formed from the center of the circle. Now, if you remember, we said that the theorem number, I forgot the number, but like the angle formed in a semicircle, So if you notice, after drawing the angle at the center, every other angle is actually on one half of the circle. So this is one side of the circle. So this is the semicircle part. Okay, is actually equal to 90 degrees. So we remember when we were saying that any side, any point where you draw the angle here will always be 90 degrees. Okay. So if here is 90 degrees, now what do they ask us to find? They say find the value of SQR. Now where is SQR at this point here? Okay? Okay, so like basically this one is easy to understand and basically easy to identify. Okay, so when you are able to see something like this going through the center, and it is given in the question that this is actually the diameter, the point going through the center of the circle, and then there's an angle of this form in terms of right angle, well, it's easy for you to remember that theorem. Okay, so now we know that one side is 62, one side is 90 degrees. So to find SQR will be equal to 180 minus 90 plus 62. Okay, so 90 plus 62 is 152. And 180 minus 152 is 28 degrees. So that is our SQR. Okay. If you have any question on this, you can ask. I would be happy to answer you. Truly, circuit geometry is not very easy, fact. But if you solve more problems, if you understand the theorems, it will be easy for you. Okay? Now let's try another one. Okay, take note we found this point as 28 degrees, okay? So let's try another one. Let's see.